Okay. So today we are going to do these five problems on the tree. So just let's wait for a minute. Okay, so for today we are going to start with this diameter of binary tree. Let's understand what is diameter in our binary tree, then we'll think about other things. Okay, so given a root in a binary tree, return the length of the diameter of the tree. The diameter of the binary tree is a length of the longest path between any two nodes in a tree. This path may or may not be passed through the root. Okay. The length of the path between two nodes is represented by the number of h between them. So if so for example one the output is 3, especially that means the length 3 is the length of the path 4213. 4213. Okay. So now, how should we solve this question, right? Let's understand and find out. So, like, um, how we can solve this? Like, we have to traverse, and the ways to traverse are pre-order, post-order, in-order, and level order. In these ways, we can traverse, and we have to find the diameter. According to this example, the diameter that taken should be this. This is answer. So what can take? So like we can assume this is our base, and we start from here. Like initially 0, 0, 0. Initially it's 0, and after that, when we move to this direction, this will uh, +1, +1. So from both sides, the +1 comes. And here we should take, let's take our max. We should take our global max, 0, and when we reach here, we will just add the both side, whatever we get from the both side. So when we are on the 2, the result should be 2. Max will become 2. And after this, we will reach here. From this side, the output will come 1 and 2, like the max one. So here should be 2, and from this side the output will come 1, and we add the output will be 3. What happened here? Glitch, glitch, glitch. Okay, so uh, um, let's assume, let's make another example, because in this the main is the output contains the 1, but the main root, but we don't want to take answer in answer a root, to take a new example. Okay, uh, let's new example. Let's try here. Okay, so what we got here, like 1, and then 2, 3, 4, 5, and that is in 6 and 7. 1, 2, 3, 4, 5, 4, 7, 8, 9, and 10. You take this one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. In every case, it contains 1. Let's make one more here. 11. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So in this case, our answer will be this. Seven, 11. This part. And this can also be, like both can be. And in this we haven't included the one. Okay, like our root. So here what we are seeing that when we reach on our root, we will check for our left and right. We have output of both sides. So it means we have to use the uh, in which left right comes first. Pre-order, post-order, and is it comes in the post-order? Hmm. We are going to use post-order because in whenever we go to root like unknown, we should have the output of both sides from left and right both. So in post starter, we first go for left, right, and then for our root or base, take it base. So this is, I think we have to use. And now the real question how to solve this. So let's assume I am on the node like 1. So I'm going to get the output of both sides. From this side, I will get 1, and from this side, what I will get? Uh, there should be three outputs should be there. For just take another number. For number two, we get three outputs. One for this side, for left side, the output which comes from left side, and the second one, the output which we get from right side, and the third one, that is the max, the global max. That is global. Let's put it here. Global max, which is equals to left plus right. Okay, so this should do what we want to. Okay, so what should be our code? Like we know we have to traverse, so let's make a function def fun with root, and there is a global max also. So let's make global max that is equals to 0. Okay. Um, when I'm on root, there is something that is written by left. So let's save in the left is equals to fun root dot left. And there is something that is written by right from the right side of this. And here we will calculate our max. That is max is equals to whatever is so we put max here. Max between left plus right. See. And left right max, we get our left, we get our right, and we also look at our max. Now we have to return something. So for return, what what we have to return we have to return whatever is bigger, left or right. So here we will take max of left, comma, right, whichever is bigger, plus 1. This we should return. And there's one thing I just want. These things should be uh, in the condition if root. There should be condition if root. And if there is no root, then for else condition, it should return 0. Yeah. So I think this will work. Let's check it out. Let's code it and check that. Is this working? Okay. So if root, so we have to make a maxi that is equals to 0, and they can make a new function that get our root, and here is non-local. See, we are going to use just for clearance. In sometime compilers don't take uh, the outer maxi, so we have to tell the interpreter that we are using the non-local maxi that is outside scope. Okay, so uh, uh, if root, let's put the if not first. If not root, then just return 0, and after this, now we know there is a root, and we first go for left, one root dot left, and same goes for right, one root dot right, and now we will update the value max. Our maxi is equals to maxi comma left plus right, and after this we have to return the max from both sides, whoever is bigger. And while returning, we are also returning the present node. Okay, the sorry, not I should not take the root. Okay, the node. Also we have to include the node. So +1 for that. And here our function. I have to call our function system, and after I have to return our C. Okay, I think this should give our answer. Okay. Okay, if left is not available, no dot left. But if okay, root, sorry. Okay, test cases pass. Let's see. Wow, I'm missing it. Okay, so it was really easy, I think, for finding the answer with recursion. But now the real problem is if I don't want to use recursion. Okay, so hectic thing is I don't want to use regression. I want to use only traversal, only loops. Why? So for that, what we can do? Okay, let's find out how we have traversed till now in our nothing is clear here. So we have solved the traversal problem earlier, and we are using the post order. Let's take some clues from there. So in post order, this is another answer. Not root return this if snap answer root. Okay. while stack. Yeah, we were in reverse order. Somewhere since I should have. Okay, here it is. Yeah, here it is. So this time we have to use this same thing, but we also have to solve, find the diameter of the binary. Okay, so let's understand again how we have solved it earlier and update some things here which may solve our question. So we have used the stack and in stack just popped out that element. So what we are going to check. I don't think this in this way we can solve our question. Okay. I think let's take previous from the solutions of others because I don't think we can traverse in this your answer. Mm, traverse six. Get back. We have to get about two and three. Well, I don't get any ways to solve this question without using recursion. So let's check the solutions about. I don't want to waste our time. And I think my voice is not that much clear. Let's give 1 minute. Let me check. Okay, so I think now my voice should be clear. Okay, where we were. Okay, we are going to see the solutions of others. And the traversal one, not the recursive. Mm. Video using DFS subsystem algorithm, memory magic, Python easy to understand solution, simple, super easy, synonymous. This guy also I've used the recursion. Processing in detail. Mm, mm, using stack, three recursive and iterative Python solution without global variable. Okay, native recursion, optimized recursive, left touch, ability, iterative plus hash map. Okay, so mapping. It means it is there are very less people who have solved this question using traversal. Stack, okay, mapping, okay, and then this is all. Let's copy this. Ah, yes, now here's the solution. We have to understand how it is working. Uh, let's make a new tray to understand this solution. One, two, three, four, 6, 7, 8, and then 11, 9, and then 10. Okay, so here what he is doing, like We first make a stack, okay, and a map. So in first in our stack there is our root. So that root is one. Okay, we got our one and the none. Okay. So while stack node we put in node the stack will also. Okay, we put one here and if node dot left and node dot not in map. Okay, well both conditions follows. So second. And it's also printed and there is nothing we have to do after that. Okay, so after this we go for again for -1, that is 2. Now we are on 2 and into into we again go for left. Okay, so 4 and same goes for 6. Okay, so now 6. And after this, there is nothing we have, so we will check for right. No left, no right. Else pop that guy out. Okay, I pop that guy. No, 6 is popped. And what we have left H, left H, left D. Okay, mapping node. Okay, node dot left. And here node dot left is none because there is nothing here. None, none. So for none is 0, 0. So in both left H and right H, right left D. So in here also 0, 0, here also 0, 0. And after this mapping node, okay, mapping node it means 6. Now 6 is being here with marks of left HH and DD. So this will give 1. Okay. And after this, we are going back to number 4. And this time, for 4, there is a right available. So 7. and 7 is appended, and for 7 also there is a left is available, that is 11. So here comes 11, and for 11 there is nothing there, no left, no right, so both side there is none. And I'm taking first H and then D. So height is 0 and D is 0, height is 0, D is 0. From both sides 0, 0. So for 11, it is going to be in 11, one common point. Now going back to our 7, and for 7 there is we will pop this guy out because for 7 uh, the node left is already in mapping. 11 is already in mapping stack. That's why we are not allowed to take again in stack. So this time what we are going to calculate, let's check out. For from node dot left and node dot right. Okay, node dot right, it is none. So for from none it always comes 0 comma 0 because of this. And because of 11 it's going to come 1 comma 1. So 1 comma 1. Height and diameter. I think what H and D is here. Okay, so we are, oh, sorry, I just forgot to stack it up. Okay, 7 is out of the stack, and I also have to put it this guy here. And while putting 1 1 plus max of left H and right H. Okay, left and right H, it is going to give 1 and plus 1, that is 2. And for max left hash, right hash, left D, right D. I think here I have done some mistake. While I was appending 6, all 1 are 0. So this guy should be 0. And same goes for 11. Okay, now left H and right H. And from left it comes 1 and here it's 0. So output will be 1. Okay, so for 7 it's 2 comma 1, and after this we are going back to our 4. So for 4, from 6 side, here comes 1 comma 0, and from right side 7 is going to give 2 comma 1. So the mapping is going to be, here is 4. For 4, it should be 1 plus max of left edge and right edge. Okay, max of left edge and right edge is 2 plus 1, it's 3. And for diameter and left edge plus right edge, left edge plus right edge. Okay, for both 2 plus 1, 3. 3, 0, and 1. The 3 is because, so here we get 3. And now 4, 4 is also in the step out. Okay, now we are going back to our 2. And 2 will get from 4 side, it will get 3 comma 3. But the right is not in our mapping, so we are going to go here first. So here it comes 5, and then here it's 8, and go for left, it's 9, and there is nothing in both sides, so it is going to give 0 comma 0 0 comma 0 because of none, and this 9 is going to become is going to give left edge and right is both are 0, that's why 1, and these all things are presently 0, that's why it is going to give 0. So 9 is 1 comma 0. After this we are going to return to 8, and then we go towards 10, put this guy in stack. Oh, 9 is also going to stack out. Okay, and for 10 also it's 1 0 comma 0 0 comma 0, and for 8 it's going to 1 comma 0, then it's going to stack out. And now when we are on 8, stack this guy out. Oh, I forgot to add this guy in here. Oh, wait, I have a call here. Sorry for that. It was family call. Okay, so for 10, it's 1 comma 0, and after going to 10, returning back to 8, and for 8 from left we are getting 1 comma 0, and from right we are getting 1 comma 0. and stack that guy out. Oh, sorry. Oh, shit. Oh, it is already stacked out. Okay. Stack that guy out. Check who is the max in H. Both are 1, 1. So 1 plus 1, 2. Because of this 1 plus max of this guy. Okay, so after this, for depth and both guys 1 plus 1, 2. Left H plus right H and left D, right D. Okay, so this will give 2. So I think better. What? Now, yeah, this will work. Okay. Okay, so for where we were, okay, we have done for 8. Now we will return for 5. Stack that guy out, and from 8 we are getting 2 comma 2, 2 comma 2, and from right side there is not, so 0 comma 0. And now take the max of H, that is 0 comma 2, so that will be 2, and 2 plus 1, that is 3. And for height, take the 0 comma 2, that is 2, and 2 0 2, which is written 2. Okay, file is also stacked out, and now we are returning to our number 2. And now the 5 is giving stack this guy out and check for left. Left is giving 3 comma 3, and right is giving 3 comma 2. And for 2 it is giving 3 plus 3, that is 6. 6 plus 1 7, and 3 plus 3 6 comma 3 comma 2, that 6 is so 6. And now we are returning back, and because there is right available, so go for right, and both side is none, so this will give 0 comma 0. So 3 will give 0 comma sorry, not 0, here it will be 1. And this will from 2, it will give a 7 comma 7 and 6, and from 3 we are getting 1 comma 0. So here the output of 1 will be 7 plus 1 8, that will give a 9, and 7 8 comma 6 comma 0, that will be 8. So here we comes at our Indian mapping, and the output is mapping root 1, and the root is 1, so here is 1, and output is 8. Let's check if the answer is correct or not. So our answer should be 11, 7, 4, 2, 5, 8, and then 9 or 10, whichever you like. So 1, 2, 3, 4, 5, 6, 7. But the output is 8. How? How? What I have done wrong here. 1.0. Let's check for the leaf nodes for 6, 11, 9, 10, 3. 6, 1, comma 0, 11, 1, comma 0, 9, 1, comma 0, and 6 is okay. 11 is also okay, and 9 is also okay, and 10 is also okay. Let's see, plus for 3. And now for 4, well, it should be 2 plus 1, 3, and uh, y- y- uh, yeah, 2 plus 1, 3, it is equal to 3, comma, and 3, yeah, it is right. This is right. 4 is also right. And for 8, 2, comma 2. From what side 1 comes, so 1 and 2, and here 1 plus 1, 2. It is also okay. So let's check for 4, 6, 8, and check for 5. 5, it's from left side there is nothing, so 0, comma 0, and from right side we'll give 8. That is 2, comma 2. So greater is 2, 2 plus 1, 3. 3 and 2. Yeah, 5 is also right. Check for 2. 2, 2, 2, 2, 2, 2, 2. Here is 2. And for 2, it's the greater one is 3, comma 3. 3 and 4. Okay, so here is our mistake. This should be, this should be 4, 3 and 6. Okay, this is right. And for 3, 1, comma, okay. Then for 1, it's 4 comma 6. It's not 7, it's 4 comma 6. So 4 plus 1, it's 4 plus 1, it's 4 plus 1, it's 5. And 4, 4, 5. Actually, would maybe also come 5 then. And answer should be 1, 2, 3, 4, 5, 6, 7. Answer should be 7. I don't know where I'm going wrong. 3 plus 3 comma 3 max is 3 plus 1 max 4 and 6. 11, 1 comma 1, 9, 1 plus 1, 2, 1, 3, and 1 from this side, 3 comma 2. Everything is right here. 3 plus 1, 4, 5, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6, 7. So here we should get 7. But but something is not right. Like if we take 1 as the base, so 1, 2, 3, 4, and 5, it's okay. 4 plus 1, 5. That is we are getting. But at 2, output should be 1, 2, 3, 4, 5, 6, 7. This this should be 7. It's 11. Oh, 11 is 0. 1 comma 1. It is 11. 1 comma 0. Okay. Wait. For 11, it's 1 comma 0. Then why I am written 1 comma 1? Okay, so it's 1, 2. It's going to return 2. That is okay. And 1 plus here it should return whichever is greater to or 1, 2, 2 plus 1, 3. It's okay. And yeah, everything is right here. 1, 1, 2, 3, 4. Oh, okay. No. Everything. Okay. Sorry. Nothing is wrong. Nothing is wrong. From here, here we are getting 3 because of 1, 2, 3, and this is 3. We are not including the upper base. So It should be 6. Yeah, 6 is our answer. But the problem is this guy has taken the mapping route 1. But in the case where our route is not included, then the answer should be come from here. So, so it means this answer is wrong. Let's try, let's run this code. I think this answer should be wrong. Is it given that the answer should always contain the root node? Length of diameter of the tree, diameter of the binary tree is the length of longest path between any two nodes. This math may or may not pass through root. This, but I have, but according to this, this answer is wrong. Yeah, it is giving answer at 2, but but uh, uh, this guy is returning mapping root 1, and mapping root 1 will return thus 5. That is wrong. It works. And it works. How? Can I make my own test case? The test case that I will use. S- 5, 6. Oh, sorry. None. None. Is it always a complete binary? Is there a possible? Oh, okay. Okay. Because there is a there is a not we can't make a single test case in which root is not included, because in each because each test case is a complete binary. I can't put none, none, comma 7, anything like 0. Nope. Uh, null. Oh, no, 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 there is possible, it is possible. So null 8. So here is 8, comma 9, and 10. I don't want 10 should be there, so null. Again null. And there is 6. I should put no here. Okay, so this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Um, let's put mm, once Mm, More into just getting to okay. This should give 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, let's run this code. Hmm, 5? How, yaar? Eh, This guy is only returning the map in route 1 and he's still getting the right answer. This guy is getting the right answer. Um, 4 and 6. Oh, okay. Sorry, this will not 5. It will be 6 because 4 plus 1 5. 6 comma 0. Oh, bro. Answer is right. Answer is correct. And the last I just 10. Pathal. Okay. Wow. Great answer. But this guy used the mapping. I was expecting to not use this. But still, we got our answer. That is enough. Let's go for our next question. And this is maximum binary tree with an integer array with no duplicates. A maximum binary tree can be built recursive from nums. So, took whole 1 hour. Oh my god. Spending on a question whole hour. Okay. Maximum binary tree, you are given an integer array nums with no duplicates. The maximum binary can be built recursively from nums using the following algorithm. Create a root node whose value is the maximum value in nums. Recursively build the left subtree of the prefix subarray prefix the left of the maximum value. Recursively we build the right subtree of the subarray suffix to the right of the maximum value. Not able to understand what he's trying to say. So this guy took 6 and team left finding the greatest guy at 3. Left is greatest is 3. On the right is greatest is 5. Oh bro, I don't think I am ready for this type of question. I think this is too much for me. Putting 6 in the mid because it is max. The largest value in the 6, the left is 3 to 1 and right is 0, 5. The largest value is 3 to 1 is 3. So left is nothing. In left there is nothing remain. And in right suffix is to 1. Child. Maybe I can solve this question by recursive method, but traversal, I don't think it is possible for me. So let's understand the question and how we can solve it. Return the maximum value tree built from nums. Okay, we have to return the tree now. Okay, nice. So 321,605. Okay. Okay, let's sorry, sorry. So here, for yeah, good set. I will make this. I can just write 321,605. 321,605. So this is our input. So in this, the guy told us, yeah, yes, yes, yes. 3, comma 2, comma 1, comma 6, comma 0, comma 5. So, I think it is pretty easy. Like, first find the greatest guy here. Greatest guy is 6. Make it root and put in left whatever guys are in left. 3, 2. And this time the 3 is greater. So that's why the all will go in here, comma 1. And same goes for 5. This in this way we have to solve our question. Find the greatest guy. Break your array into parts in left and right. So in a function, we are giving its like array, like we are giving its left and mid and right, and then making the mid our new node. So make this guy node is equals to whatever function this guy is given tree node. Tree node mid. In this way it is converted into the node, and for node dot left here goes our function should um okay, so I think so no, no, no. Okay, I think I understood. In function, we are just putting our array, okay, and before making any changes, we just have to index of max index equals to array dot index of max in array. Okay, so in this way we can find the index, and after this we are going to make a new node that will be tree node, that is tree node, and putting the array with max underscore index, and now we have to do something about its left node dot left equals to whatever is our function, and now we have to give array uh, here and the index, and same goes for right. Function array max underscore index plus one, because we are not taking the max index guy, and this will be okay. So in this way we will get our left and right, and we have to return our node, because these function are returning the nodes that we are making. So okay, one more thing that I haven't added, that will be if not array. If there is no array, then just return none. Oh, sorry. In this way, our left, whatever the function written the left, the node dot left become none. Okay, so let's code this and let's see is this working or not. So first thing first, if not array, that is here nums, return the none. So no. And if there is none, then just find the max index is equals to array dot. I don't remember all the methods, so let's check. Is this works or not? Max of array. And after this, make a new node. The new node is equals to tree node with the value of nums max underscore index. Hmm. And for node dot left, we are putting the self dot upon still city construct max array. Just copy it. Copy, paste. And this time we have to give the nums with an initial value till the max index. Okay. And for node dot right, and for node plus right, we just have to get all the right side elements and then just return the node. Okay. So let's see this works or not. Array. Oh, sorry. Here it's nums. Uh, Array is not defined. Okay, it works and it works. No, what is time? 8:42. Okay, I think today we will only able to solve two questions, not four. So now the traversal one, like how we should traverse in this for left and right. How we can solve this code. Like let's so here what we can do, like array and file array, um, stack. We have to find the max and then break into, and also have to maintain that connection. So um, like what we have to do, make a dictionary and in 6, 3, 2, 1 and 0, comma 5. No, 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 no. Mhm. This will not work. What we can do here, 6. We have to get our 6, and also we have to pinpoint that on 6 dot left it should be these guys, and on 6 dot right they should be these guys. I I think we can use a stack. Wait. Like uh, let's make a stack which contain our array. Where is our stack? Okay, in a stack, we first put our first we put our 6, uh, 6 with 6, and here we say it's in left 3, 2, 1. Right is 5. Okay, and in the place of using stack, let's use queue. Okay, and because 6 will become 6 become a node, so here it's node. Okay, so because it is queue, we just um, because we already know 6 is the main root, we will save that as a root 6. Okay, and then while as we pop this guy, uh, new should come because 3 is the main character. Sorry, 3 is the main. So we make 3 a new node and connect this 3 with 6m. Um, no, it is not working. It is not. working. Let's go back. Node 6, comma, left and right, 3, 2, 1, and 0, comma 5. These things should be known. Okay, as we pop this theme, we will find the new three, node 3, and in left there is nothing, and 2, comma 1. as we pop this guy out, these two things will come in the first pop. We will get these two things, and as we pop this guy out in a second, what we are going to get, because there is nothing left, we get nothing, and we will get the node 2. Here it's nothing, here it's 1. I'm seeing was for 3. As we pop this guy out, we get node 0, and both sides are empty. And then popping this guy out, we'll get node 1, and both sides nothing. I think we can code this. Let's check it out. Like, so for code, um, what we have to do. Okay, first it's def function, whatever is our root. Okay, oh sorry, not a root, it's array, it's nouns. Okay, and here we have to, if not nouns, just return the none. And if there is something in that, so just if if there is something in that, so just we have to make a queue. um, sorry, PQ. Ah, PQ with and we are making a new node. So node, whatever is oh, we also have to find the max index. Yes, so nums dot index, and then max of nums. This will give the max index, and we have to make a node, and that will be our answer. So the next line will not be a queue, but we will make a root that we will return last, and put this as tree node with the value of nums max index. Okay, and now we have to make a queue. DQ um, with the value. Let's not confuse some, just make a DQ, and Q dot append the main first root, and then whoever is on left, in left should be nums, mm, max index, max index, and nums max index plus 1. This should be in our queue. Okay, so after our queue is made, so now we will run our code for a while queue, and then we will pop out the elements, and those elements will be node and the left array and the right array. Okay, will be equals to q dot on left. Okay, this will give all the things that we need, and now we have to find um, we know node, and now we have to find the max from this side. So if left underscore array, if this guy is there, then just find the max index, and because max index is already made, so we are not allowed to use this variable. So let's make a new variable like left array max lamp and index lami. Okay, so lami should be equals to left array dot index of max. Okay, so in this way now we know left index, and now we know the left index. Now it means we can make a new node, that is left node. Let's name it left node equals to tree node, and left underscore array with the value of lam that have index. Okay, this will make our new left node, and now we have to connect node dot left is equals to left node. Now we have form our connection, and after making After making connection, we have to put this new left node in our queue. Queue to append our left node and then left underscore array with line. And sorry, line plus one. Okay, so this will append the left, and this whole thing we have to do for right also. If right plus array do the same things. And I think this will complete our code. And after this, coming out from the while loop, just return the our root. So let's code this and check if this works or not. Okay. So here I have to import um, collections, import DQ, and after this, what we have to do? Yes, if not nouns, just return the none, and now from the max index, that should be equals to nouns dot index max of nouns, and after this, just make a new node that will be our root. Tree node. Hmm, tree node, and in tree node put the value nouns, nouns index. This will make our root, and now we have to make our queue. DQ, and in DQ we have to append our root, and then mums with ref, sorry, max underscore index, and mums underscore index plus one. In this way we know left and right, and now we will run our loop till q. Okay, in q, while q, okay, yeah, pop that out. Note left array l arr r arr left array, and right array, q dot pop left. This will pop these guys out and put in this. And after this, just if LARR, if left array is there, then just make what I have to do is that Lamy, okay. Lamy equals to Lamy equals to uh, LARR dot index of max of LARR. This will find the index, and now we have to make a left node. Left node equals to um, tree node. Tree node, and with tree node will contains the LARR, LAMI, the value LAMI, and now we have to connect this guy with our node dot left is equals to left left node. Now connection is established, and now q dot append this left node. Left node comma LARR LAMI, then LARR LAMI plus 1. This we have to append. Okay. And for right, we have to do the same thing. If RARR RAMI, right array max index dot index max, and then RARR right underscore node equals to train node with RARR RAMI programming node dot right is equals to and yeah, if LRR is not there, then just put the mm, no template already none, so I don't think we have to put the else condition here. Okay, so dot right equals to right underscore node and q dot then right node comma LRR and RAMI RAM LRR this guy. This will put return with. Let's see if this works or not. Oh, too big. And it works. Wow, it really works. It is not a best solution, but it works. Let's see what is the best solution we have. Uh, mm, no, 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 no. Sure, 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 sure. Okay, we have the traversal solution as well as the recursion solution. I think we are done for today. It's already approx 2 hour. Let's stop the stream and thank you for being together with me.